Welcome back to another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we're looking at some data about the All Blacks, and we are going to use some data cleaning and exploration techniques to look, explore, clean, and visualize this data. So to get started, what we'll do is we'll install the necessary packages that we'll need. For this, we're going to be using the Tidyverse as well as dplyr. I've already done that, so we'll just move on to the exploration and the cleaning of the data. Before we get to that, I want to go ahead and take a look at the data that I've already imported. We can see the opposition, the date, what the result was. The result is just the difference of the score. So it would be the All Blacks minus the opposition's score. So if the score is negative, it means that the All Blacks lost. We also see the location, how many debutants were in the game, as well as some more data regarding each team. And then we also have the rating of both the All Blacks as well as the opposition. So to get started with the data exploration and cleaning, we're going to go ahead and take a glimpse at the data. When we go ahead and run these first lines of code, we see that the glimpse function allows us to see how many rows and columns there are, as well as the column names, and then it gives us the data type that they are. So this is a great way that we can just kind of take a general approach and a general look at what the data we're dealing with is. After looking at the row and column names as well as the data types, we'll use the unique function, and we're going to utilize the opposition name to see what teams they played against, as well as if there are any missing data. So if there are misspelled names, if there are NA names, we can do further analysis on that and then drop those values if need be. So we can take a look at the teams that they played against here. Okay. After that, we're going to utilize a bar plot, and we're going to sort that data by the result, and we want to sort it by the decreasing order, so from smallest to largest. When we run this code, we see, let me zoom in, we see that it's listed in descending order, so we have some negative scores here representing All Black losses. It looks like a couple zeros, which would signify a tie. And then we see a lot of positive values, meaning that the All Blacks won. After utilizing the bar plot, what we can do is we can utilize a summary function of the result. And what this is going to give us is, I gotta run it again. When I run the summary function for the result, it shows us the min, the max, and the quartile range, as well as the median and the mean. Now, if we wanted to visualize that, we can just simply use the box plot function, run that, and then when we enlarge this graph, we see that we have a box plot, and this shows, if I can enlarge it a little bit, this shows the same data that we just saw with the summary function, but it also allows us to see any outlier data. So these circles here at the top would be considered outlier data points. The last one that we're going to use for the results is a histogram. So when we utilize the histogram, it's going to show us the spread as well as the density of the results. So as we see, that most games for the All Blacks were won within a 20-point differential. So this is going to show us if there's any skew. We see there's a tiny bit of skew here, but it doesn't look like it's anything significant. If there was a significant skew, again, we can go look at what those data points may be and then see if those are valid data points or if we need to do some data cleaning on that. So after we utilize that for the results, we're actually going to do the same thing for the opposition rating, as these are going to be the two main data points that we're going to be looking at. So when we look at the summary of the opposition rating, we see that the min is 61.85 and on average we're looking at 81.82 being the average opposition rating. Again, we can utilize a box plot to visualize it, and we'll zoom in again, and we see here that there's actually some outliers on the lower end of the spectrum outside that first quartile range. And then again, lastly, we'll utilize a histogram plot, and we can see the spread and the density of opposition ratings, and we see that the majority of them are in between that 80 to 90 rating range. Okay, now that we've looked at our data, we're going to utilize the filter function here, and what we're going to look at is we want to look at the opposition name, what the date was, the result, what the opposition rating was, and what the rating of the All Blacks was at the time of the game. But what we want to do is we want to filter where the result was less than 0, in other words, where the All Blacks lost, but where the opposition's rating was less than what the All Blacks rating was. So in other words, we want to look at games where the All Blacks lost when they were not supposed to have lost based off the rating. So when we run this, we see that we have 22 entries where the All Blacks lost when their rating was higher than the opposition's rating. So this is a really interesting thing. Unfortunately, there's not enough data given in this data set that we can do further analysis on it, but it would be interesting to see how many penalties there were, if there were yellow or red cards, or what the score ratio was in terms of when during the game the points were scored. So that would all be additional info that would be great to have to do further analysis on these 22 games where the All Blacks lost when they were the underdog, or when they were not set to lose. But looking back onto our data set, we're going to move on with their analysis, and we are going to start and we're going to look for Pearson's R. So like I said, we're going to be utilizing opposition rating and result as the main two that we're going to look at. So we're going to utilize the pipe function and the summarize, and utilizing the correlation function to find Pearson's R between the opposition's rating and the result. When we run that line of code, we see down here at the bottom that the correlation between opposition rating and result is a negative correlation. It is a negative 0.6. Pearson's R is a negative 0.6. We know that there is a moderate to strong negative relationship between the opposition's rating and the result of the game. So as the opposition's rating gets higher, the result gets lower. It might even pass into that negative range. The next thing we're going to do to further analyze our data set is we are going to run a linear model analysis on the opposition rating and the result of the game. So when we run these two lines of code utilizing the LM, if I can select all the code here, all right, it gives us a lot of numbers at the bottom here. So the first thing that it shows us is our residuals, and then we also see our coefficients and the intercepts. So a residual is the difference between the actual data and the expected data, but we'll get into that a little bit more in a little bit. So we can see that the slope of the line is going to be negative 2.19, and we'll visualize it in a second so you can see what I'm talking about. We also see our p-value right here. The opposition rating is a tiny p-value. So what that suggests is that it suggests that the results are replicable. That's important for other people that are doing their analysis, that hopefully they should be getting the same results. As we go on, we're going to look at our multiple R squared, and we see that we have a 0.3636 as our R squared. When we look at the multiple R squared of 0.3636, that tells us that 36.36% of the change between the result is due to the change in the opposition's rating. For in our other histograms, we can actually run a histogram of our residuals, And this is going to show us the spread and the density of the residual. So we see that a lot of our residuals run from this negative to 20, with the most of them being from negative 10 to positive 10. So that's a good sign to see that there's not a very, very large residual out here in the higher percentages, which means that we do have a good best fit line. We've looked at all the numbers. We can actually go ahead and use ggplot using geom point and the geom smooth function to give us our best fit line to show us the relationship between the opposition rating and the result. So when we pull up our graph, we can see the negative slope. So the relationship between the opposition rating and result is negative. As the opposition's rating increases, the result decreases. This data is great, but I really feel like it's incomplete. It would be great if we could see the number of penalties that were had, if there were any yellow or red cards, who the referees were. Data like that is going to just go above and beyond to allow us to improve our abilities to run linear models, as well as to build predictive models regarding the success or potential failures of a team. I also want to reach out to any coaches that are watching that have a data set that needs analyzed, but they're not sure who to look for. Reach out and connect. I'd love to help you do that. I want to make data-driven decision making possible for all coaches and teams. That way we can decrease injury likelihood and maximize athletic potential.